All right, so question 5.27 from the reading, right? They tell us that I've got 0.25 grams of an organic compound. I burn that organic compound in a bomb calorimeter, and the temperature goes from 24 degrees Celsius all the way up to 26.43 degrees Celsius, right? And they tell me the heat capacity for the calorimeter is 4.13 kilojoules per degree Celsius. So how much heat in kilojoules is released? So you actually, because they're just looking for overall heat, you don't need that mass at all. They tell you the mass, you don't have to do anything with it. And that's where I think other people were kind of running into problems with this calculation, because it's just going to be the Q for the calorimeter equals C delta T. So Q for the calorimeter, my heat capacity is 4.13 kilojoules per degree Celsius, and my delta T is 2.43 degrees Celsius. So multiply those together, and my Q for the calorimeter, right, like 10 or 11 something, 4.13 times 2.43. Yeah, I get like 10.0359 kilojoules of energy, right? And so that's for the calorimeter, right? What's that? Exactly, that was my next question. So what does that mean for the reaction? For the reaction, it's going to be negative, and I would say 3 significant figures, right? Based on my temperature and everything else given there is 3 significant figures. So yeah, I would say negative 1.00 e to the 1 kilojoules for that question. Question 27 on the homework, right? Negative 1.00 e to the 1 kilojoules. Yeah.
Why is it a significant figure based off of the gram?
So we don't use the 25 grams for significant figures because it wasn't in our calculation, right? We didn't do anything with that number in our calculation. If we did have to find moles and they wanted to know the heat of the reaction in kilojoules per mole, then yeah, we would convert that mass to moles, and then we would be limited to 2 significant figures. Here they just wanted to know how much energy that reaction released. But
the question was like, does the E or does the H, then we have to find the moles.
if it was asking for the heat of the reaction, and they, in the previous question, they told you like kilojoules per mole. Here they just said for that reaction, the kilojoules of energy released. So we don't have to do anything with moles for that naphthalene. So yeah, some people were trying Q equals MC delta T with the mass of naphthalene. Naphthalene is not going through the temperature change. The calorimeter is, so that doesn't help us. And then we didn't have to do anything with moles because they weren't looking for moles. So yeah, it was just Q for the calorimeter, C delta T for that calculation. Yeah. No, yeah. Q. All right, now we're going to go to the practice exam.
Yeah, I have a question on question 8.
Yeah.